I want to introduce BlueDop to you, especially to tissue viability nurses, to GPs, to all those who are involved in vascular clinics, and arterial disease in all its forms, but specifically the diabetic foot, which we think is the biggest challenge. Pretty well everybody has a problem. This is a conventional dot, the kind that you'll use every day of the week. It has to be encapsulated, but it's the kind of thing you're used to. You may be even used to the display that you can get on the brain. But what's different is that it can do three things that the standard systems cannot do. So I'm going to show you those. We've got a tablet computer with the brain. We've got some specialist software. We've got an algorithm that calculates pressure from just the waveforms that you can pick up with a Doppler. And those waveforms carry a lot of information. It's been thrown away over the last 50 years since people have been measuring ABpI. We've only been listening for the onset of a sound, whereas in fact a wealth of information is obtained in the actual waveform shape, which I'll show you. So here's the probe, here's the egg. That's locked on to the device. You can hear the hiss maybe for the locking on. We'll select some software. This is Vascular Expert. That's the one I hope you'll use to do your tests. It's very straightforward. And if we can just need to measure, we need a reference pressure, so we take a reference pressure using a conventional cuff. Here's a simple Omron, 18 pounds on the web. This is perfectly good for taking a reference pressure on the right arm. Let's assume we've done that. We feed that into the machine. You've got a display which you're used to, you may see on your Huntley machines, or you've got those or similar. So they're very useful. We know the waveform shapes are very informative. However, we don't have a means of formally doing anything with them. Let's show you on this simulation just the kind of information that we can get. I say it's a conventional Doppler, but it doesn't need a cable, so that's quite useful. Let's see what we can get on our forgive me while I get up a pretty waveform. And it's onto the wrong thing. So now, this is simulating a normal leg. You're familiar with the triphasic or biphasic waveform. Systems, let's do that again. It will stop automatically when it's happy, statistically, if it's actually got a reasonable, believable physiological shape. Here it's thinking about it, but it's not happy with it. It's very fussy. And if for some reason it doesn't like it because of small variations, it will make a diagnosis, I'm pretty sure. I know this is supposed to be a normal leg, so let's see what it comes up with. 4 screens worth. There, it's taken the average. The blue indicates a normal arterial system. The green means pressures are in the normal range, and we have the equivalent of ABpI, which is in the normal range. There is a difference between our ABpI and the conventional one in that our one is based on mean pressure ratios, The old style one is on systolic, so this can only go to 1 max. So 0.9 is good. We can also get 2 other bits of information that you don't get from any other system in the world. It's unique. The perfusion pressure in the foot, here is 82, and the vascular reserve, which will tell you if you have critical ischemia. That vascular reserve, which is high now, will go down to 0% when we approach critical ischemia. When we actually pass through the critical ischemia stage, we'll get negative values here. So it's actually very informative and very useful, because that critical point, which we need to know about, which is where we need to intervene, either do surgery or some kind of intervention to save tissue. We know that point now, it's quite precise. That point will be when that perfusion pressure is exactly half the central, or when the vascular reserve is 0%. One is dependent on the other, so that comes out of that calculation. What happens with disease? Well, let's see on our simulation how the machine deals with that. Decide to like this. If I've got a little bit of handshake, it might not. It likes it. So that's now red. So the red marker tells us there's significant disease somewhere from the ankle all the way up to the heart. We don't know where, but we know it's significant. Well, we can see that there the ABpI has gone down to 0.68. The fusion pressure is reduced, that's for the foot. And we've now only got 36% of vascular reserve. So it's still a viable leg. This person will get claudication, but they will not have tissue problems, certainly not from the arterial problem. So this is the kind of information the machine will make the decision for you. As long as you can get a reasonable signal where the machine does not sulk and refuse to give a result, you pretty well know you've done the right thing, and that you've aimed the probe in the right place. You need have no knowledge about the significance of specific shapes. Rely on this automatic system to give you that answer. We found in an early test series for several hundred cases an accuracy of around about 97%. You may not be able to achieve that. This is certainly much higher than the accuracy in diagnosing significant disease using ABpI. So in summary, we've got a whole lot of other useful things that will really work and really be useful clinically. First of all, we're saying do not rely on ABpI to indicate disease. ABpI is labile, it changes with flow level. Flow level changes with wound healing. Wound healing may be nothing to do with arterial disease. It follows that ABpI is not a great indicator or reliable indicator of arterial disease. What perfusion pressure is a great indicator of is a limited supply to the tissue, and that's what most of us are concerned with. Is it limited? Is it approaching critical level? That it can answer by giving you the number there, and it can answer you in a more vivid way by looking at the vascular reserve. We know then if that goes to 0 or less than 0, then we're looking for somebody who needs to have something done rapidly in order to preserve the tissue. So I'll leave it with you there. This is a new system. There's no system anywhere like it anywhere else in the world. You can use it immediately with your skills that you've already obtained over many years at obtaining good signals from difficult legs. You should be able to, within a short time, be getting the kind of results I can get off this machine. So thank you for listening, and we'll tell you more later.